Hello, this is Radhika Dhanal, research scholar from Department of Technology, Shivaji University, Kolhapur. I'm presenting my research topic, aspect-based sentiment analysis using topic modeling and machine learning. It uses the concept of latent Dirichlet allocation for aspect extraction and the concept of the bird for sentiment polarity. Moving ahead with the introduction, the aspect-based sentiment analysis, it's a specialized task in natural language processing, focusing on sentiments towards specific aspects within the text data. For example, the product reviews. Consider a cell phone, then you can consider its camera, its resolution, its screen, its memory as the variety of or various aspects of it. So we are more interested into the sentiment associated with these aspects also about the overall sentiments regarding a particular product, or it could be anything, any area. So ultimately, moving ahead, I would say that it analyzes the sentiments expressed towards specific aspects in text data into three categories, that is positive, negative, and neutral. You can find its applications in e-commerce, hospitality, healthcare to analyze the customer opinions, and the list goes on. Let us look into the challenges in the traditional aspect-based sentiment analysis models. The very first one is the limited adaptability. So when you have a new domain, then the earlier models are less adaptable to it. So that's our main focus. Second is a lack of aspect level sentiment evaluation. The current existing models, most of them work on just the overall sentiment of the entire review or a statement rather than the aspects. Then the next is the potential bias due to the specific training data set. So the training data set matters a lot. If you have trained it particularly on a special domain, then certainly it will behave in that way. And hence there could be a bias due to it. The next is the traditional machine learning and deep learning models, which suffers from the domain specific biases that is already that we discussed. And then we have the lack of generalizability when trained on specific data sets, and then these people directly evaluate the overall polarity, often overlooking the aspect level sentiments. Talking about the literature survey, there are a lot many people who have worked on it. But talking about the few and the latest ones, we have this called as RGT and the LCF model. It stands for the local context focus mechanism. It is based on the multi-head self-attention mechanism. The next one called as the RGT, and then you have called as multi-graph convolutional network, where the authors have aimed to correct the errors that were introduced by the dependency parsers and the complexity of the entire sentence and the structure of the entire sentence. So these people have worked on it. Then further we have multi-weight graph convolution network, and the last one is context-free dynamic mask, context features dynamic weighted model. Now, if you talk of the results of it, the accuracy ranges between 78% to 83%. These people have worked on certain benchmark data sets. One is the laptop data set, and the other is the restaurant. And hence, that would be the reason why we also have taken the same data sets. Now, adapting these models to the diverse domains remains a challenge. So, attention based or graph based approaches may be limited when they deal with large scale data sets or real time applications, and the certain reason is the requirement of the high computational resources. Moving ahead, let's talk of the current framework and its overview. So as I've already said, it's an combination, it's an integration of LDA and BERT. It's a latent Dirichlet allocation and the BERT model. Data sources undergo certainly pre-processing is required, tokenization, lemmatization, stop word removal. Then we apply the term frequency and invert document frequency to identify the word weights. And then ultimately we go ahead with the concept of LDA to extract the topics and the associated aspects for that particular topic. Later on, the BERT model is used for sentiment classification, and the parameters that we use for performance are accuracy and the macro F1 score. This certain concept or the technique that we have used, it provides a granular insights for business strategies in numerous areas, and it's a more, should I say, it's a more fine-grained approach. So again, let's talk about the proposed solution. It's been named as LDA-TF BERT. So it combines the LDA for aspect extraction and TF BERT for the sentiment polarity evaluation. The advantages certainly are the improved accuracy and granularity, and it overcomes the traditional limitations of the existing earlier models. Talking of the architecture of the LDA-TF BERT model, you can see into the diagram. The review text is given as an input here, and the minute it's given as an input, the very first step or the initial step of the LDA-TF BERT model involves extracting the review text from the corpus data set. So the very first is the extraction of the reviews that we have from the corpus data set. And then later on, this text is subjected to the aspect extraction model and the polarity extraction model. So you can see here, aspect extraction model uses this LDA, whereas polarity extraction model uses this TF BERT concept. The output of this aspect extraction model is certainly the aspects. These aspects are further given as an input to the polarity extraction model, where the BERT calculates the polarity of the aspects. I repeat, not only the polarity of the aspects is computed, but also the polarity of every sentence or the review is also computed. And then we combine the polarities calculated for the aspect as well as the polarities that have been calculated for the entire sentence. And based on both the things, ultimately we comment on the sentiment of that entire review or the sentence that we have. Moving ahead, let's deep dive into the details of LDA. So LDA, uncovers the hidden patterns in the review data sets, and it extracts the topics as well as the related words. Certainly, these related words are termed as aspects. Now, we have used this Python library, which is used for the visualization, where you can see there are certain topics that are been identified, and when we scroll onto it, all the words that are related to that particular topic can be viewed. The one with the highest coherence score can be decided or can be chosen as an aspect. So there could be lot many topics. There could be many aspects related to that topic. Now it depends on the user, and the user can then manually select 5 or 10 or 15 or as many aspects related to the topics, as well as can select the topics also. This LDA model, it is actually a powerful method for uncovering the hidden patterns and structures within the review data sets. Let us denote the review data set with a capital R. And then we can say that it analyzes the entire data and generates the topic vectors by modeling the likelihood distributions, which works on this concept of likelihood distribution. In the context of LDA, this particular figure, you can see here, there are few things to observe. This N represents the position of the word within a specific review, whereas alpha and this eta, these are the parameters that govern the topic and the proportions respectively. So this alpha and eta, that matters. It governs the parameters. These are the parameters, I say, that governs the proportions and the topics. While beta, if you look here, is the the one which evaluates the mixture of words across the different topics. So beta is a topic and then a blend of all the words into it. Then we have capital K. Capital K, it signifies a total number of topics. Then we have this theta R. It represents the distribution of topics for each particular review. So it's the distribution of topics for a particular review. And then we have Z, R, comma, N. It denotes the matrix. It's the matrix for the reviews and the words. Whereas W, R, N represents the likelihood distribution of words. So here, as I've already said, capital R denotes the total number of reviews, and the capital N represents the number of words present in the reviews. These are the formulas that are related to calculating the aspects or the probability that a particular word will belong to a particular topic and the corresponding coherence score. The higher is the coherence score, the more relevant is that particular word, and there is a chance that it will be selected as an aspect for a particular topic. Next, we move on towards the second half part, that is a TF word model for polarity classification. Now, all the topics have been found. We know all the variety of aspects that belong to the particular topic. We choose few of those aspects, and these now aspects are given as an input to this word model, which will now calculate the polarity for each sentence and the particular aspect. So as you can see here, it's written, extracts the polarity of aspects and the reviews, uses the fine tuning with word for accurate sentiment classification. There are certain hyperparameters that we need to decide what should be the value. That certainly will based on how we execute it, and then we decide upon certain values, and LDA certainly for aspect extraction and topic modeling. So this is the BERT model you can see here. So this X represents the different sentences, and whereas N represents the word in that particular sentence, this entire sentence is given as an input to this TF BERT. And then we calculate this tuple. So what this tuple exactly consists of, this AI, this certainly A stands for the aspect. The next is OI, which stands for the polarity of that particular aspect, and SI represents the polarity of that particular review. Certainly, this mod T is the entire number of tuples that you will have based on how many sentences you have. Moreover, the hybrid joint extraction approach that we are using here, it utilizes a position tagging technique for defining aspects present at starting and end point of a sentence, represented as this is AS and AE, start and end. Similarly, the position tagging technique is also used for calculating the polarity present at the starting and ending point of a sentence, represented as OS and OE. So this is the polarity at the starting and at the end, and this is for the aspect at the start and aspect at the end. So that's what is ASAE and OS and OE. Moving ahead, the position encoding process is used to get the position of aspects and its associated polarity. And finally, the BERT, which utilizes all these tokens, it further and then it represents it as this kind of vector. So it's a contextualized representation. So it's a CR of E. I would simply describe this as a list of tokens. So it's a list of all the overall tokens that we have. During fine tuning the BERT uses the output from its final layer to classify the tokens as input to the softmax, this classifier. This softmax classifier, then it's a function which is applied to the logits, which is the raw scores, and then it ultimately it's produced by the classifier, which then converts this scores into probabilities, right? We ultimately are interested in the probabilities. So these probabilities actually indicate the likelihood of each class. So what's the probability? So is it positive, it's negative, whether it's neutral? For sentiment analysis, and then the one with the highest probability will be put into that particular class. So this is the formula that we have. So after the process of classification of tokens, we have the outcomes are separated as sentence polarity and the aspect polarity. So you can see here, and then ultimately the combined result gives you the sentiment polarity. So I've already explained these concepts. Let's move ahead with the experimental setup. So you have used the data set as SEM Eval 2014 task 4, which has actually a combination of two, that's the laptop and restaurant. Why these? Because most of the earlier work has been performed on this laptop and restaurant data set, and hence it's considered as a benchmark. But if you look at the title, we are also interested in multi-domain. So we have decided to have a multi-source data set, which was separately constructed. So the data of hospital and the Amazon reviews, as well as the laptop and restaurants, all was combined together. And this multi-source data set is again a separate data set that has been used. These are the configurations, the requirements, the system requirements. Yes, these are the hyperparameter settings. Obviously, after executing it for a lot many times, then we have decided about the dropout rate to be finalized as 0.1, batch size as 32, the learning rate, max epoch, and then maximum sequence length, and finally the active optimizer that was chosen was added. So you can see these values that have been finalized after certain executions and trials and errors. The evaluation matrix that has been used is certainly the accuracy and the macro F score, which is the average of precision and the recall across the classes. Yes, you can see here a special table which shows the sentence. For example, a tech support would not fix the problem unless I bought your plan for $150 plus. So these people are talking about some kind of problem. So the aspect identified is problem, and certainly if you read it, you can find out that it's a negative approach, and hence the polarity which has been found is -1. So this is the sentence. This is the corresponding aspect that has been found and the corresponding polarity. A setup was easy. So certain, we are talking about the setup, it's the aspect, and then the polarity is certainly positive, which is represented as 1. So 1 represents positive, -1 represents negative polarity, whereas 0 represents the neutral polarity. So these earlier, what we have seen were the polarities that were calculated for every aspect that we have chosen, and which was computed by that LDA model. Then we move ahead with the sentence polarity. So you can see the same sentences in this table, and this time the sentence polarities are again put into 3 categories: negative, neutral, and positive. And based on that, you can now see here. If you look at, this is 0.0313, this is 0.5616, and this is 0.4069. Certainly, this value is a larger one, and hence it falls into which category is a neutral, and hence the polarity associated is 0. Here, if you look into the second, it's 0.78, which is the highest value, and hence the polarity is decided to be as negative, that's -1, and so on. So as I've said, the execution was done on the laptop data set. These are the results you can see. The accuracy on the laptop data set with this LDA TF-BERT model gives us the accuracy of 82.19%, whereas the macro F1 score is 79.52. Whereas for the restaurant data set, it gives you as 87.26 and 81.27. So it's certainly at par, in line with the earlier existing models, or in fact, we can say it's much, I mean, not much, but certainly better. So here you can see the earlier models that we had discussed during the literature survey. These are the values for the accuracy and the F1 score. And this is the current proposed model, that is LDA TF-BERT, which was implemented, and it gives us the accuracy of 82.19 and 79.52, the F1 score, which is certainly higher than the earlier ones. Similarly, if you look for the restaurant, then you can see here the earlier results. These are 83, 75, and so on. Whereas the LDA TF-BERT gives you the accuracy of 87.26 and 81.27. See, in order to check its robustness, we have also checked it on the single data sets like laptop and restaurant. But our ultimate aim is to check it on the multi-source data set, which is a combination of hospital data, Amazon products, and variety of mixed combination and variety of domains. So it should work on multi-domain. So if we execute it on multi-domains, it is certainly found that it works better also on the multiple domains. And the results that were found are 87%, and certainly it's good. There were no existing, or there are no other models which have worked on similar kind of this, but which gives you this kind of or a higher accuracy. So ultimately, I would simply conclude saying that the key findings are that LDA TF-BERT outperforms the existing models in terms of accuracy and adaptability, potential for real world applications in market analysis, and certainly the customer feedback interpretation will be higher. It provides a robust approach towards aspect-based sentiment analysis. It certainly combines the concept of topic modeling and deep learning instead of only going with deep learning, and gives us an improved sentiment analysis model and shows superior performance and generalizability across multiple domains. What can be considered as the future work is we can go on validating this model, its performance on variety of data sets. We can even try if it works for multimodal data sets. This time we have only worked on the text, but yes, there were a lot of combination of variety of domains. So that's how we can check its performance or validate it in future. These are the certain references that I have referred during this research work. Thank you. Thank you so much.